Yes,
Yes,
sir.
sir, you are audible.
Yeah, listen, yeah, everyone have to join with your domain mail ID, ma'am. Otherwise, you won't get attendance. It is very difficult to post the attendance if you join with your personal email. Okay, all of you join with your domain mail ID. Domain mail ID means your rule number. After that, iare.ac.in something is there. No, all of you register with that mail ID, not with your personal mail ID. Are you getting? Yes. Join with your domain mail ID, then only you can get the attendance. How many are there? 31. 31 participants are there. We'll see. Yeah, shall we start? How many are there? 35 participants are there. What about others? No? Yes. Okay, shall we start now? We'll wait for 2 more minutes. Okay, in the last class we have done this problem. Okay, right? You got the answer for that?
Yes, sir.
Huh? Shall I discuss once again, or shall we go for another topic? Yeah, this is what we got in the last class, last problem. Okay, in the last. Okay, is it audible now? My voice is audible to you?
Yes, sir, you are
Yes,
audible.
sir.
Yeah. Okay. Okay, thank you. Yeah, in the last problem is asking calculate the temporary and permanent hardness, but he gave only permanent hardness causing salts, not the temporary hardness causing salts. Okay, he gave calcium sulfate 6.8 milligrams, calcium chloride, magnesium sulfate. Okay, here is asking in the question calculate the temporary and permanent hardness of water sample which contains 6.8 milligrams of calcium sulfate, 33 milligrams of calcium chloride, 40 milligrams of magnesium chloride, and 24 milligrams of magnesium sulfate per liter of water sample. Okay, already you know the formula how to calculate this. This is what we got. Okay, temporary hardness and permanent hardness of water sample. Temporary hardness is 0 because bicarbonates all are chloride, sulfates, and okay, chlorides and sulfates. Then we need to calculate only permanent hardness. Permanent hardness by doing this, we got, okay, 5 milligrams for the calcium sulfate. Hardness causing salt for calcium sulfate is 5 milligrams, and calcium chloride is 29.72 milligrams. Magnesium chloride is 42.10, and magnesium sulfate is 20 milligrams. By adding all these, you will get 96.82 milligrams. 96.82 milligrams. Okay, this is what we have in our syllabus. See this. We already completed this introduction to the hardness of water and causes of hardness. Okay, introduction means what are the uses of water. Okay, how the hardness is caused in the water. Okay, hard water, soft water, and what are the causes of hardness. Okay, temporary hardness and permanent. Okay, types of hardness. Here we have discussed about the temporary hardness and permanent hardness. Okay, next expressions and units of hardness. Expressions and units of hardness. We have discussed the numerical problems based on this. Okay, hardness. Okay, numerical problems. Now the next topic is estimation of hardness of water by complexometric method. Okay, estimation of hardness of water by complexometric method. After this, we have, based on this, we have numerical problems. Okay, next topic is estimation of hardness of water by complexometric method. Okay, we need to estimate how much amount of hardness present in the given sample of water by complexometric method. By nothing complex we are taking is EDTA, ethylene diamine tetraestic acid. We'll see what happens. Okay, it is an experiment. Earlier we have this experiment in our laboratory. Okay, we are going to see this how we are going to estimate this hardness of water by complexometric method. Only 46 participants are there. Shall we start, or we'll wait for 46 are there out of 64, 65? 45, one, okay. Okay, anyhow, I am going to start. Yeah, this is what estimation of hardness of water by EDTA method. Estimation of hardness of water by EDTA method. EDTA is nothing but by using this complex ethylene diamine tetraestic acid. What this experiment involves? Okay, like in your experiments, every experiment you will have aim, principle, procedure, and finally we have calculations. Okay, same thing we have to do here. Okay, what is the aim of the experiment? Okay, aim of the experiment is to estimate the amount of hardness present in the given sample of water. Estimation of hardness of by here the aim of the experiment is to estimate the how much amount of hardness present in the given sample of water. Okay, by complexometric method. Okay, principle. Okay, it have 3 steps. Principle. Okay, procedure. We have 4 steps. Again, in the procedure we have step 1, step 2, step 3, step 4. Okay, in the procedure we have 4 steps, and finally we need to do the calculations. Are you getting? Yes. What happened?
Voice is not clear, sir.
Voice is not clear.
Yes, sir.
Now. Yeah, here it involves okay, some internet issues here. Your internet connection is unstable. We'll see. Okay, principle, procedure, and calculations. Principle, procedure, and calculations. Okay, here in the principle, in the procedure, we have 4 steps. Principle, what is the principle behind this estimation of hardness of water by DTA method? We need to discuss. Before that, okay, here we have. Okay, what are the chemicals we are going to take for estimation of hardness of water by EDTA method? Okay, what are the chemicals involved in the estimation of hardness? Here, the chemicals are EDTA, ethylene diamine. Okay, the full form of EDTA is okay, ethylene diamine tetraestic acid. Now, these are the chemicals we are taking. Ethylene diamine tetraestic acid. I will show the structure. Okay, this is a complex structure, and the EBT, erythrochrome black tea. Okay, here erythrochrome black tea is an indicator. and the buffer solution. Okay, the use of buffer here is to maintain the constant pH mark. Okay, the pH you need to maintain is 9 to 10. 9 to 10. Okay, and the standard water. Okay, standard water is calcium carbonate solution. Here we are, by using this we are going to perform the first step. Okay, calcium carbonate solution. Okay, next one is tap water and the boiled water. First step is we need to find out the molarity of the solution. Okay, molarity. What is molarity, ma? Molarity definition. My voice
Number
is
of moles
audible.
of solute present in 1 gram of
Number of moles of okay, the chemicals we are taking is these are the chemicals, ma. EDT, ethylene diamine tetraestic acid, EBT,
Number of
erythrome
moles of
black tea.
solute present in 1 liter of solution.
Yes, very good, very good. Okay, number of moles of solute present in 1 liter of solution is nothing but molarity. Okay, here the everything. Okay, in the 4 steps we are using this formula molarity of the given standard water. EDTA, we are taking the chemicals are ethylene diamine tetraestic acid, EBT, erythrome black tea. Okay, this is a mixture buffer, ammonium chloride and ammonium hydroxide. By using these two chemicals, we are going to prepare the buffer. The use of buffer is okay to maintain the constant pH. Okay, pH of 9 to 10. And standard water, we are taking standard water and the sample water sample, that is tap water and boil water. By using this, we are going to estimate the amount of hardness present in the given sample of water. Next, coming to, okay, here we need apparatus. Okay, apparatus required for this estimation of hardness is conical flask. Okay, conical flask, already in the picture it is shown. Is it visible, ma? This is a conical okay, 250
Sorry, your
ml
voice
conical
is
flask
breaking.
need. Burette is a 50 ml. Okay, in liquid. Yeah. Okay. Someone is saying it is audible. Okay. Is now? Is it good? Is it good, Mano? Still, it is breaking.
It's fine, sir. Now.
Okay. 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 Thank you. Yeah. Here, apparatus required for this estimation is conical flask. Okay, 250 ml conical flask, burette 50 ml, pipette 20 ml, beakers 250 ml beakers. Okay, these are the apparatus required to estimate the hardness of water by EDTA method. Apparatus of conical flask. Yeah. Okay. Apparatus. Next, what we need to also. Okay, what actually is estimate how we are going to perform this experiment. Okay, how what here water okay, already know this hardness of water is due to the presence of calcium and magnesium present in the water. In the water. Okay, analysis of this calcium and magnesium is present in the water can be analyzed by implementation. Okay, stand indication. Okay, in the Okay, shall I rejoin? Sorry, your connection is highly unstable. Could you rejoin, sir? Shall I rejoin again? Shall I leave and again? Need to join? Is it audible, ma'am? Okay, here the analysis is done by complexometric titration using the standard EDTA. Okay, in the burette, always you are going to take EDTA solution. Okay, we are going to take EDTA in the burette. In the beaker, we need to take the different samples of solutions like standard water, tap water, and
Their voice is not audible.
okay, here the main thing present in the experiment is
That disturbance వస్తుంది sir.
Wait a minute. అది చూస్తున్నా Yeah, now is it audible, ma? Yes. Is my voice is audible?
Yes, sir.
Okay. Here the analysis is done by complexometric titration. Okay, complexometric titration using standard we are using standard EDTA as a titrate to maintain the constant pH. Okay, buffer solution used to maintain the constant pH. Okay, the analysis is done by complexometric titration using analysis. Is a type of volumetric analysis where the color complex is used to determine the end point of the titration. This complexometric colored complex. Okay.
Their
That we are
voice
determining
అసలుకే
end point.
రావట్లేదు
Okay,
sir.
the amount of and so in the voice.
Their voice సరిగా రావట్లేదు sir.
Now is
No sir.
no.
Very laggy.
Okay, wait. I will join with wait. Wait a minute. I am joining with another network. Yeah, now it is clear, ma? Now the voice is clear?
Somewhat better, sir.
Okay, fine. Yeah, here the analysis is done by complexometric titration using standard EDTA. Here, the EDTA, what the chemical, the use of this EDTA is always we are going to take this EDTA in the burette. Okay, burette, always we are going to take EDTA, and in the beaker, conical flask. Okay, here in the before. Okay, EDTA, we are going the solid chemicals like EDTA, we are going to take in the burette. Okay, burette, and this EBT, we are going to add, it is an indicator we are going to add in the conical flask. Okay, this ammonium chloride, ammonium hydroxide acts as a buffer solution. Okay, what is the use of this buffer solution is to maintain the constant pH, and this different samples of water like standard water, tamp water, and the boiled water. Okay, standard water, hot water. Okay, and the this one is boiled water. The analysis is done by complexometric titration using standard EDTA as titrant and EBT as an indicator. EBT as an indicator. Here, complexometric titration is a type of volumetric analysis where colored complex is used to determine the end point. Okay, whatever the color you got, no, that is the end point. You can say that when the color changes appears on the by adding the EDTA to the conical flats, wherever the color changes observed, that is called as end point. Okay, ethylene diamine tetraestic acid. Okay, this ethylene diamine tetraestic acid is a reagent. Okay, it forms a complex with the different metal ions. Okay, EDTA forms a complex with the different metal ions at different pH. pH. Calcium and magnesium form complexes at with EDTA at 9 to 10 pH. 9 to 10. Okay, already I said that. What is used because of this reason we are using this ammonium chloride and ammonium hydroxide to maintain the constant pH buffer solution. Here, EDTA forms a complex with metal ions at different pH of calcium and magnesium, forms complexes with EDTA at pH 9 to 10 to maintain this constant pH. Okay, already I said that to maintain this 9 to 10 pH, we are going to use buffer solution. Buffer solution is a mixture of ammonium chloride and ammonium hydroxide. Ammonium chloride and ammonium hydroxide acts as a buffer solution. The main use of this buffer solution is to maintain the constant pH. Okay, here coming to the structure of EDTA. Okay, ethylene diamine tetraestic acid. Here, ethylene diamine ethylene. The formula for ethylene is CH double bond CH2 double bond CH2. Okay. Next, it is saying diamine. Diamine is two amines, NH. Okay, but ethylene diamine tetraestic acid. Okay, 4 acids. Here, 4 acids we have to take. CH2, actually CH3 COOH. Okay, acetic acid is the formula for acetic acid is CH3 COOH. Like that, we need to take 4 acetic acids: CH3 COOH, CH3 COOH, CH3 COOH. But here the valency of carbon is okay. Already it is connected to the nitrogen. So one of the hydrogen we need to remove. That is CH2 COOH. Okay, like that here also the carbon present in the ethylene, it is also 5. Okay, so we need to satisfy the maintain its valency. We need to take CH double bond CH. We need to remove this. Okay, CH2 COOH and CH2 COOH. This is what the actual structure of EDTA, ethylene diamine tetraestic acid. Ethylene is CH2 double bond CH2 diamine, two amines. Okay, NH. Okay, here N. Okay, the valence of nitrogen is 3. Okay, here now nitrogen is connected to CH2 COOH, CH2 COOH, 4 amines. Okay, ethylene diamine tetraestic acid. Same thing here it is explained. Here EDTA, EDTA we call it as ethylene diamine tetraestic acid. Ethylene diamine tetraestic acid is a complexometric indicator. Okay, it is a complexometric indicator consisting of 2 amine groups. Here see, these are the 2 amine groups. Okay, NH is the 2 amine groups and 4 carboxylic groups. Carboxylic groups means nothing but acetic acid groups. Okay, it consists of 2 amine groups and 4 carboxylic groups called as, this acts as a Lewis basis. Here we call this as hexadentate. EDTA called it as hexadentate ligand. Ligand is nothing but which donates a pair of electrons. Okay, here the capacity of this EDTA as, okay, hexadentate ligand, because why we are calling this hexadentate ligand, because of its competency to donate 6 pair of lone electrons due to the formation of covalent bonds. Okay, it has a capacity to donate the 6 pair of electrons due to the formation of covalent bonds. Okay, here the complex agent are less soluble in water. Complexing agents are less soluble in water, and most of them are free acids. So this is used in the volumetric analysis. By this, the reason why we are using this EDTA is it has complexing agents are less. This is used. Why we are using this as EDTA only we are taking means it has less soluble in water, and most of them are free from acids. Most of the ions present in them are free from the acids. So that is the reason we are using this EDTA in the volumetric solutions, volumetric analysis. Okay, before using them, what we need to do means we are going to convert into sodium salts. Okay, sodium salts of EDTA. Okay, sodium salts that are feasible in water. Okay, we are removing this hydrogen. In the place of hydrogen, we are keeping the sodium salt of EDTA. We call it as sodium salt of EDTA. Sodium salt of EDTA. Why? Because means it is feasible in water and less solubility in. Okay, it has characteristics of less soluble in water during the titration. That is the reason we are taking. We are converting this acid groups. Okay, whatever the. Yeah.
ಯಾವಾಗ ಓ ಬಿದ್ದೈತಿ ನೀನ್ ಇವಾಗ ನೋಡ್ತಾ ಇದ್ದೀಯ
Yes, Sindhu Reddy. Yes, whatever.
More.
Yeah, here why we are going to convert this okay, acid group with the sodium salt means sodium means they are feasible in water. The reason is feasible in water and less soluble in water. That is used for the titration. That is the reason we are taking it. We are converting this acid groups into the sodium salts. Okay, it is a hexadentate ligand because it has a capacity to donate the 6 pair of electrons during the formation of covalent bonds. Okay, this is about the structure, explanation of structure of EDTA. Why we are taking only EDTA? Because here the reason is it consists of 2 amino groups and 4 carboxylic groups, and which acts as a Lewis basis, and it is a hexadentate ligand. EDTA is a hexadentate ligand because the reason is it consists of 6 pair of lone electrons which is used for the formation of covalent bonds, and this is less soluble in water and most of the free acids. Okay, that is the reason we are using it is as a volumetric analysis, and we are converting this hydrogen, okay, H plus ions, the sodium salts with feasible water because they are characterized with less soluble in water, and that is used for the titration. Now coming to the structure expression of erythrome black tea. Already we have discussed about the EDTA, okay, EDTA, complex metric titration. Now we need to explain what is the use of this erythrome black tea. Okay, erythrome black tea. It is a indicator in alcoholic solution. Yeah, what is this? In alcoholic solution of erythrome black tea, that we call it as EBT. Okay, it is the full form of EBT is erythrome black tea. Erythrome black tea. Okay, here the structure. Okay, it is 1,1 hydroxy 2 naphtho azo 6 nitro 2 naphthol 4 sulfonate. Okay, this is the structure. Structure of erythrome black tea is 1,1 hydroxy 2 naphtho. Okay, 1,1 hydroxy 2 naphtho 6 nitro 2 naphthol 4 sulfonate. Okay, the IUPAC name of this erythrome black tea, IUPAC name of erythrome black tea is 1,1 hydroxy 2 naphthol azo 6 nitro 2 naphthol 4 sulfonate. Okay, yes.
బ్రో బయటికి ఏమైతుంది
Hello, D4. Okay, it is used as a indicator. It is used as a indicator. Already I said that the EBT used as a indicator. Here erythrome black tea. Okay, EBT are indicators that changes from the color. It is helpful to change the color from blue to wine red. Okay, actually the color of EBT is blue color. Color of EBT is blue color indicator. Okay, here adding the EDTA from the burette. Okay, the blue color changes to the wine red color. That is, we call it as end point. End point. Okay, wherever the end point will get, no, we need to note down the readings. Okay, here erythrome black tea are indicator that changes the color from blue to wine red color when they complex with calcium or magnesium ions. Okay, when they are complex with calcium or magnesium ions. Okay, the end point of this complexometric titration using EBT as indicator is detected. Okay, here the color changes from wine red to blue color. Wine red to blue color. Okay, what is the use? Here we are going to explain about the use of EBT, erythrome black tea. Okay, erythrome the black tea, the structure is 1,1 hydroxy 2 naphtho azo 6 nitro 2 naphthol 4 sulfonate. 4 sulfonate. Okay, it is used as a indicator. It is used as a indicator. Why we are taking it as indicator is, okay, actually the color of this EBT is blue color. Okay, the color of EBT is blue color. Okay, here wherever the change from the blue to wine red color when the complex is with, okay, calcium or magnesium ion, that we call it as end point. End point of complexometric EDTA titration using EBT as an indicator is detected. Okay, there we need to stop the titration and we need to take the readings. Okay, that is the end point. The color changes from the wine to red color is nothing but end point. End point. Now yeah, now coming to the principle. Already we have discussed about the structures of this EDTA and EBT. Now we need to discuss about the principle, procedure and calculations we need to do. What is the principle behind this this one? Okay, estimation of hardness of water by EDTA method. Here the principle is the calcium and magnesium ions present in water are responsible for the hardness. Okay, hardness of water is due to the presence of calcium and magnesium. Already you know this. Okay, this ion forms wine red color. Okay, these ions form wine red color. Okay, the color of EBT is blue color, but the presence of this calcium and magnesium ions present in the water is responsible for the wine red color complex. Okay, this ions forms wine red color complex with indicator. Indicator means nothing but EBT. You're taking EBT as an indicator. Okay, and this metal ions forms stable complexes with EDTA. It forms stable complexes with EDTA. Now, what happens? Now, what we need to do means the principle is here metal ions. Metal ions are nothing but calcium and magnesium ions present in the water. Okay, it reacts with EBT indicator and forms wine red color complex at the pH 10 mark, at the pH 10. Okay, now what we need to do, okay, calcium and magnesium EBT reacts with, okay, calcium and magnesium ions reacts with EBT, it forms wine red color complex. Okay, calcium EBT or magnesium EBT it forms, which is the wine red color, okay, which is unstable, this is unstable. Now this reacts with, okay, EDTA, which we are going to take in the burette. EDTA forms colorless complex. Colorless means nothing but it, okay, it forms colorless complex with metal ions, that is calcium and magnesium ions, as calcium EDTA or magnesium EDTA present in the complex. Now whatever we got in the wine red color complex, okay, calcium EBT or magnesium EBT, it is an unstable complex now. Okay, wine red color, this is the unstable complex. Now it reacts with EDTA. Now it reacts with the EDTA. It forms colorless stable complex. This is the unstable complex. Okay, now whatever this complex form is reacts with EDTA, which we are going to take in the burette. It forms colorless stable complex and it removes the EBT as a blue color. EBT as a blue color. In the picture it is shown ma. Okay, initially it was, okay, wine red color complex. Okay, the color of solution is wine red is the first one is the wine red color, the second one is a blue color. Okay, finally you will get this complex, that is wine red color, and the blue color will be separated out. Blue color will be the separated out. Okay, the metal ions like calcium and magnesium ions reacts with EBT. Okay, it reacts with EBT indicator and forms wine red color complex at pH 10. Okay, at pH 10. Okay, here calcium or magnesium EBT reacts with calcium EBT or magnesium EBT. It forms wine red color, which is the unstable complex. Now this unstable complex reacts with EDTA. EDTA we are going to take in the burette. EDTA, it forms colorless complex with metal ions. Forms calcium, okay, metal ions like calcium and magnesium as calcium EDTA or magnesium EDTA. Here this is the calcium EDTA or magnesium EDTA, which is the colorless stable complex. This is the stable complex. Calcium EDTA and magnesium EDTA is a stable complex, and it removes EBT as the separate one, that is byproduct blue color one. Okay, already you know this, the color of the complex, okay, EBT is blue color. Now procedure one, it involves four steps. First one is preparation of, step one is, okay, it is very important, preparation of standard hard water. First step is preparation of standard hard water is a step one. Okay, step two is standardization of EDTA solution. Step two is standardization of, okay, already I've said that the procedure involves four steps. Standardization of EDTA solution. Okay, step one is preparation of standard hard water, standardization of EDTA solution. Third step is standardization of hard water. Step three is standardization of hard water. And the step four is we are going to find out standardization of permanent hardness of water. These are the standardization of, okay, these steps we need to discuss one by one. Standardization of permanent hardness of water. Okay, these are the four steps involved in the procedure. Step one is preparation of standard hard water. Second one is standardization of EDTA solution. We need to standardize the EDTA solution. And the third step is standardization of hard water. Fourth step is standardization of permanent hardness of water. These are the four steps involved in the procedure. in the estimation of hardness of water. 4 steps involved in the estimation of hardness of water. One is preparation of standard hard water, standardization of VTTA solution, standardization of hard water, and the standardization of permanent hardness of water. Coming to the first step, what we need to do? Okay, step 1 is, okay, we need to take the, okay, this 1 gram of calcium carbonate. This is the calcium carbonate chemical. This is the, we need to weigh the about 1 gram of calcium carbonate. Okay, 1 gram of calcium carbonate, and we need to transfer into the 1000 ml standard flask. 1000. Here the step 1 is we need to find out the molarity. Okay, already you know the formula how we are going to find out the molarity. Molarity is number of, okay, moles present in 1 liter of solution. Okay, here weigh accurately about 1 gram of calcium carbonate and transfer into the 1000 ml standard flask. 1000 ml standard flask through the funnel. Now, after adding this, okay, this is after adding this calcium carbonate into the 1000 ml standard flask through the funnel, dissolve. We need to shake. Okay, dissolve it in minimum quantity of dilute HCl. Okay, and make up the solution up to the mark. Okay, on the standard flask there is a mark will be present. Up to that we need to take, that is we call it as 1000 ml standard flask. Okay, make up the solution up to the mark with the distilled water in 1000 ml standard flask. In 1000 ml standard flask. Okay, now we need to calculate the molarity of the standard hard water. Okay, here the step 1 is preparation of standard hard water. Okay, now here we need to find out the molarity of standard hard water. Molarity of standard hard water is here weight by molecular weight of calcium carbonate. Okay, molarity M is equals to, okay, weight by molecular weight. Weight by molecular weight into, okay, 1000 by V in ml. V in ml. V in ml. Weight by molecular weight by molecular weight into 1000 by V in ml. Here already you know this. Okay, weight of weight, how much grams we are taking? 1 gram, right? Weigh accurately, in the question is saying that weight accurately 1 gram of calcium carbonate. Okay, same thing, weight we are taking as 1 by molecular weight of calcium carbonate is 100. Okay, molecular weight of calcium carbonate is 100. 1 by 100 into 1000 by, we are making for 1000 ml. Okay, 1000. Okay, by doing this you will get, okay, by calculating you will get 0.01 molar. Okay, 0.01 molar, that is M1. From the step 1 we got M1. Very simple, ma. Just we need to take the calcium carbonate, 1 gram of calcium carbonate, and we need to transfer into the 1000 ml standard flask. 1000 ml standard flask through funnel and dissolve it in the minimum quantity of dilute HCl. Now we need to make up the solution up to the mark, and we need to distill water in 1000 ml standard flask. The step 1 is to find out the molarity of the solution. Molarity is nothing but weight by molecular weight into 1000 by V in ml. Okay, here the weight is given is 1 gram. Weight accurately about 1 gram. 1 by 100. Molecular weight of calcium carbonate is, already you know that, 100 into 1000 by 1000, you will get 0.01 molar. Any doubts up to here? 0.01 molar. Okay, this is M1. Step 1 is preparation of standard water. Here we are going to find out the molarity of standard hard water. Molarity of standard hard water is weight by molecular weight into 1000 by V in ml. Okay, weight is saying that weigh accurately. The weight is given as how much weight we are going to take means 1 gram. 1 gram means 1 by 100 into 1000 by 1000. You will get 0.01 molar. That is M1 is 0.01 molar. Okay, this is M1, preparation of standard hard water. preparation of standard hard water. Now, second step is standardization of EDTA solution. Step 2 is standardization of EDTA solution. Okay, what happens? What we need to do in the step 2? Now, whatever we got in the step 1, okay, what we got is we have prepared the standard hard water. Now, what we need to do is this molarity of the standard hard water is 0.01 molar. Now we need to prepare it out. No, what are the step 1 we got? We need to keep aside. The step 2, we need to do the standardization of EDTA solution. This EDTA we are going to take in the burette mark. Okay, EDTA we are going to take in the burette. Now pipette out 20 ml of step 1 solution. Step 1 is calcium. We have prepared step 1 as standardization of hard water. That is, we are using by taking the calcium carbonate. We have prepared this one. Yeah, pipette out 20 ml of calcium carbonate solution into the clean conical flask. Okay, pipette out 20 ml of calcium carbonate solution into the clean conical flask. Add, we have add 2 ml of buffer solution. Add 2 ml of buffer solution. Buffer is nothing but it is a mixture of ammonium hydroxide and ammonium chloride. Pipette 20 ml of step 1. This is the step 1. Whatever we have prepared 1000 ml. What is the molarity of the step 1 is 0.01 molar. Okay, this solution only we are taking in the standardization of the step 2, that is standardization of EDTA. How we are going to standardize the EDTA solution? Now pipette out 20 ml. This from the whatever we got 1000 ml, from the 1000 ml we are going to take 20 ml. Okay, 20 ml of calcium carbonate solution into the clean conical flask. The clean conical flask. To that, we are taking the, see here, we are taking the conical flask mark. Okay, this is a consider this as a conical flask. To this, what we are going to take means, this calcium 20 ml of what? Calcium carbonate solution. Calcium carbonate, that is what we got in the step 1. 20 ml of calcium carbonate solution into the clean conical flask. To this, what we need to add means 2 ml of buffer. Buffer is it is prepared by mixture of sodium hydroxide, sodium chloride, and ammonium chloride and ammonium hydroxide. Ammonium chloride and ammonium hydroxide. We are going to prepare this buffer. The main aim of this buffer is to maintain the constant pH. Now to this again, we need to add 2 to 3 drops of EBT indicator. The color of this EBT indicator is blue color. Blue color. Now what we need to do means, here by adding this EBT, the solution becomes wine red color. Wine red color is the solution we got here. Tell me what were the solutions we have taken in the clean conical flask. We have taken 20 ml of hard water, that is calcium carbonate solution, whatever we got in the step 1. To that we are added 2 to 3 drops of EBT indicator plus 2 ml of buffer solution. 2 to 3 drops of EBT indicator and 2 ml of buffer solution. Now the complex the color of the complex is wine red color complex. Now the color of the complex here, whatever we got, the color is wine red color complex. Now what we have to do means we need to titrate. We need to titrate. How we are going to titrate? Here, take EDTA solution. Already I have said that EDTA, always we are going to take EDTA in the burette. EDTA in the burette. EDTA solution in the burette. After titrating with EDTA solution, color of the solution is red color. So we need to titrate till the wine color changes to the color. Red color changes to the blue color. Okay, wine color changes to blue color. Nothing but into point. Take the EDTA solution in the red. After titrate with EDTA solution till wine red color changes to the blue color. Okay, that is the end point. That is the end point. Like that, we need to do the titration. Okay, note the burette readings. How much where you got where the color changes appeared. That is, you need to stop the reading and note down the burette readings. Note down the burette readings. Okay, here note the burette readings and repeat the titration 2 or more times. Okay, we need to repeat it to get the concurrent values. Okay, you need to get concurrent values. So you need to repeat it for 2 or 3 times to get the at least 2 values to be a concurrent. Means same values we need to get. Any doubts up to here? Step 2. Is anyone is having the doubts?
No, sir.
Everything is clear, right? Okay. Yeah. Here we need to titrate, note the burette readings and repeat the titration to get the concurrent values. Concurrent values. Now what we need to do means the end point is here the wine red color. Wherever the wine red color turns to blue color, that is the end point. We call it as end point. Now stop the burette reading and note down the reading. Note down the reading. I will show you how we, in the calculation part, I will show you how we are going to take these values. Now, already I said that we have 3 steps. Step 3 is standardization of hard water. Standardization of hard water is the step 3. Okay. Principle also is given. Okay. By adding this, initially we got wine red color. Okay. And by adding this, okay, wine red color, EDTA forms colorless complex with metal ions, that it forms blue color complex. That is nothing but end point. Same thing we are following in the procedure. Whatever we discussed in the principle, the same thing. Initially, what we need to take hard water. To the hard water, we are taking EBT and EBT. Okay, Echrome black tea. And to the adding buffer solution, use wine red color complex. Now, what we do is wine red color complex. This complex is unstable complex. Now, to that unstable complex, we need to titrate with EDTA. We need to titrate with EDTA, which we are going to take the burette. Now, EDTA forms colorless complex with metal ions. That is nothing but calcium EDTA or magnesium EDTA. This is a stable complex, and the color of this solution is okay. EBD blue color. Blue color complex is blue color. Now, the step 3 is standardization of hard water. We need to standardize the hard water. Okay. In the step 1 is we need to find out the molarity of the calcium. Okay, hard water. Okay, molarity of hot water. We need to find out molarity by the molarity formula. Weight by molecular weight into 1000 by P in ml. Okay, we are going to measure. Okay, we are taking 1000 ml of water. So weight is given as 1 by 100 into 1000 by 1000. We got 0.001 molar. 0.01 molar. That the whatever the step 1 we got, we need to take the solution 20 ml of solution from the step 1, that is 0.01 molar. The step 2 is we need to pipette out 20 ml of calcium carbonate solution. Calcium carbonate solution is pipette step 1. Okay, we are going to pipette out 20 ml of the solution in conic flask at 2 ml of buffer solution. To that we need to add buffer solution and 2 to 3 drops of indicator. Okay, it gets wine red color. Wine red color. Wine red color is unstable. Already we discussed in the principle. Now we need to take this wine red color unstable complex with EDTA, which we are going to take in the burette. Now we need to take EDTA in a burette after titrating with EDTA solution till changes to the blue color. Okay, that is nothing but end point. Okay, we need to stop the readings. Now we need to note down the burette readings and we need to repeat it to get constant values. 2 or 3 times we need at least 2 values, 2 times the same value. That is nothing but concurrent values. Step 3, we are going to take that is sample water, that is tap water. We are titrating tap water. Step 2, taken whatever the solution we put in the step 1. Here step 3, taking okay, pipette out okay tap water, okay 100 ml of tap water in a beaker. Now from the 100 ml we need to pipette out 20 ml. Pipette out 20 ml of tap water in the 250 ml conical flask. 250 ml conical flask. 250 ml conical flask. Again same procedure. See, again I am taking the conical flask. To this I am taking okay 20 ml of 20. Okay, step 3 is standardization of hard water. Here we need to pipette out 20 ml of tap water into a 2 ml conical flask, 250 ml conical flask. To this we need to add 2 ml of buffer solution and add 2 or 3 drops EBT indicator. Sorry, EBT indicator. Same procedure. Now we what it forms water 20 ml. This we are adding 2 ml of buffer solution and 2 or 3 drops of EBT indicator. Okay, now the complex formed is, what is the color mark? Okay, this is a complex is wine red color complex. Wine red color complex we got. Wine red color complex is the unstable complex. Wine red color is the unstable complex. Now we are going to titrate this with burette. Okay, EDTA solution which we are going to take in the burette. Titrate the wine red color. Okay, here it forms wine color complex. Wine red color complex. Okay, which is unstable. Now we need to titrate this wine red color. Titrate the wine red color solution with EDTA taken in the burette. EDTA taken in the burette till blue color end point is obtained. Means wine red color changes to the blue color. This is the point. Till a blue color end point is obtained. Okay. Now stop the burette. Okay. Stop the burette. Now we need to take the readings. Okay. Now same thing. Repeat the titration to get the concurrent values. Same again. Okay. In the step 2, we have taken the step 1 solution, but in the step 3, we need to take the tap water. we need to take the tap water. Pipette out 20 ml of tap water in 250 ml conical flask, add 2 ml of solution and add 2 drops of EBT indicator. It forms wine red color, which is unstable complex. To this red color complex, we need to titrate with EDTA, which we are going to take in the burette. Blue color in point to get the concurrent values. Okay, need to do for 2 or 3 times to get the concurrent values. Now coming to the step 4, standardization of permanent hardness of water. Step 4 is standardization of permanent hardness of water. Here, water we are saying is boiled water. How we are going to prepare this boiled water means, okay, the step we are going to find out the molarity of the given solution. Step 2 is the going to standardize the integration. Step 3 is standardization of hard water. Step 4 is standardization of permanent hardness of water. This is breaking. Standardization of permanent hardness of water. Is there no voice clear now? How we are going to prepare this means, here in the step 3 we have taken the tap water. In the step 4 we need to take the sample water, that is a boiled water. We need to prepare the boiled water. Pipette out 100 ml of hot water sample in a beaker. Pipette out 100 ml of hot water sample in a beaker containing 250 ml. Okay, we need to pipette out 100 ml of hot water sample in a beaker containing, the beaker is 250 ml beaker, and we need to boil till the volume reduces. 100 ml has to reduce it to 50 ml. 100 ml has to reduce to 50 ml. What happens means, all the bicarbonates of calcium and magnesium ion decomposes to calcium carbonate and magnesium hydroxide. Calcium carbonate and magnesium hydroxide respectively. We are taking the 100 ml of water in a 250 ml beaker. 250 ml beaker. To this, 100 ml of hot water sample in a 250 ml. This is a 250 ml beaker. Now we need to boil it until the 100 ml becomes 50 ml. 100 ml of water has to become 50 ml. Until that time we need to boil it. What happens means, all the bicarbonates of calcium and magnesium ions decomposes to calcium carbonate and magnesium hydroxide respectively. Now what we need to do, because it is boiling, now we need to cool the solution. And filter the water into a beaker. Then we need to pipette out this 50 ml. We got 100 ml and we have reduced it to 50 ml. Now cool the solution and filter the water into a beaker. Then we need to pipette out. We got the 50 ml into 50 ml beaker. We need to pipette out 20 ml from the 50 ml. 20 ml of this cool water sample into a 250 ml conical flask. Same procedure, right? Step 2, 3. Here we need to take the 20 ml from this and need to cool the sample in a 250 ml conical flask. Same procedure again. We need to take the conical flask. Conical flask. To that we need to add, here we have that is 20 ml of boiled water. We call it as boiled water. Sample water, that is boiled water. 250 ml conical flask. To this again we need to add 2 ml of buffer solution and 2 or 3 drops of EBT indicated. 2 or 3 drops of EBT indicated. Same procedure what we have done in the step 2 and step 3. Now what we get is wine red color, which is the unstable complex. Wine red color complex, which is unstable. This is the wine red color complex, which is unstable complex. Now what we need to do is, okay, whatever the unstable, okay, now this we need to titrate with EDTA, which we are going to take in the burette. Okay, titrate the wine red color solution with EDTA taken in the burette. Now titrate the EDTA burette till where we need to get the blue color solution, that is the end point is obtained. Blue color is the end point, and repeat the titration. Repeat the titration to get concurrent values. Repeat the titration to get concurrent values. Okay. Step 4 is the 100 ml of in a beaker containing 250 ml, and we need to boil till the 100 ml has to reduce to 50 ml. What happens here means all the bicarbonates of calcium and magnesium ions present in the water decomposes to calcium chloride and magnesium hydroxide respectively. Now we need to, because it is a boiling, we need to cool the boiled water. Cool the solution and filter the water and put out this sample into 50 ml, 2 ml buffer solution and 2 or 3 drops of EB indicator. Same procedure, same we need to do. Now we need to titrate this. Need to titrate this with EDTA, which we are going to take in the plate. Titrate the solution EDTA taken in the plate. Titrate the white color solution with EDTA in the burette till a blue colored solution end point is obtained. Blue color solution end point is obtained. Same, we need to repeat the titration to get the concrete values. Concrete is nothing but similar values. We need to get the 2 or 3 similar values. Okay. Repeat the titration to get the concrete values. Coming to the calculations, how we are going to calculate this one. Okay, we have already said that principal procedure we have steps and finally calculations. Okay, first what we have find out, step 1 is finding the molarity of the standard hard water. Okay, molarity, how much we got in the step 1 is 0.01 molar, right? We have taken, that is weight by, okay, here molarity M1 we are going to find out in the step 1, that is M1 is equals to weight by molecular weight into 1000 by V in ml. Okay, we have taken 1 gram, 1 by molecular weight of calcium carbonate is 100 into 1000 by 1000. By doing this you will get 0.01 molar. 0.01 molar. Okay, this is a step 1. Step 1 is M1. Now in the step 2, what we are taking is, okay, whatever we have 1000 ml, okay, the molarity of this 1000 ml solution is 0.01. Now in the step 2 is molarity of EDTA solution. How we are going to standardize means, okay, the calculation is, okay, M1 here we call it as, M1 is whatever we got in the previous step 1. Okay, calcium molarity, that is molar, calcium carbonate molarity. Okay, calcium carbonate. Okay, the formula for the finding the molarity of EDTA is M1V1 to M2V2. Okay, now to standardize the EDTA solution, okay, the formula to find out is M1V1 is equals to M2V2. M1V1 is equals to M2V2. Okay, already we know the M1. M1 we got 1. Okay, we need to know the M2. M2 equal to M1 V1 by, okay, M1, sorry, M2 is equals to M1 V1 by V2. M1 V1 by V2. Okay, here already you know this M1. M1 is the calcium carbonate molarity, that 0.0 molar. Okay, we don't know this V1. Whenever we do the experiment, then only we came to know, okay, how much. Okay, V1 is volume of calcium carbonate solution. V1 is volume of calcium carbonate. And is how much amount of EDT has consumed. Okay, where the end point you will get no, that is we are looking at V2, volume of EDT. Will get no, that will take it as V2. Okay, volume of V2. Okay, V1 is volume of calcium carbonate. Volume of calcium carbonate by substituting the, okay, M1 that is 0.0. I have connected to other network also. The same thing is. Okay, here molarity standardization step 2, we need to find out the molarity of EDTA. That is how we are going to find out, means by using the formula, that is M1 V1 is equals to M2 V2. Okay, already know the M1. Okay, we need to know the M2, that is molarity of EDTA solution. M1 is equals to V2. Here M1 is the step 1, whatever we got, that we call it as calcium carbonate molarity 0.1. V1 is here, V1 is volume of calcium carbonate. How much volume we are taking? Okay, that is we are taking as 20 ml. 20 ml of calcium, and V2 is how much EDT consumed. How much volume of EDT consumed. By substituting this, you will get the 2, that is molarity of EDTA solution. Substituting values, you will get the molarity of EDTA solution. Now come to the molarity of hot water sample. Calculate this hot water sample. The formula to find this hot water sample is M3 V3 equal to M2 V dash. Okay. Same thing that we have in the step 2 V2, not to confuse, getting 2 dash. Okay, here already you know that what the value get in the step 2, that is M2. How much, whatever the value will get, no, that is M2. Need to find out molarity of hot water. Molarity of hot water is M3 here. M3 to M2 V3. M2 V2 dash by V3. M2 V2. Okay, here M2 you will get from the step 2. Finally, how much you will get? No, that is M2, and we here M3 is the molarity of hot water. We need to find out how much molarity of hot water. M2 is the EDTA molarity. EDTA molarity means step 2 molarity. How much amount molarity you got in the step 2, that is EDTA molarity, and V3 is the volume of hot water, and the V2 dash is the volume of EDTA consumed, that is burette readings. At the end point you will get no. Still the voice. No one is responding. Is my voice audible?
Yes, sir. Breaking, sir. Your voice is breaking.
Your voice is not clear, sir.
Now still not clear. Still it is happening. His voice is clear. Network connection is unstable. Audio breaking. Now tell me, how is my voice? Respond anyone? Same, the voice is coming. Yes. Is my voice is audible?
Yes, sir.
Okay. Okay, fine. Yeah. Yeah, we are discussing about the calculation part now. Step 1, step 2. Step 1 we got is molarity, that is M1 is equals to 0.01. Step 2 we got is, okay, M2. We are going to find out M2 by using this formula M2 V2 by M3 V3. Okay, by using this M1 V1 is equals to M2 V2, we need to find out M2. M2 is equals to M1 V1 by V2. M1 V1 by V2. Here M1 is whatever we got in the step 1, that is step 1 we got is 0.01 molar, and V1 is volume of calcium carbonate. How much amount of calcium carbonate we have taken? How much volume of sample we have pipette out? That is volume of calcium carbonate. And V2 is how much amount of EDT has been consumed. The burette readings. This is V2 is burette readings. V1 is M1 is calcium carbonate molarity, that is the step 1 molarity. Whatever we got in the step 1, that is the M1. M2 we need to find out. V1 is volume of calcium carbonate. V2 is volume of EDTA consumed, that is burette readings. Okay, by substituting all these values, you will get the M2. M2 is equals to M1 V1 by V2. M1 V1 by V2. Now, in the next step, what we need to do means molarity of hard water sample. M3 we need to know. Okay, M3 we are going to find out by M3 V3 is equals to M2 V2 dash. Okay, M2 V2 dash. Why we are taking dash means in order to not to confuse in the same V2 V2 we have taken in the earlier step 2. So we are taking as V2 dash. Okay, M3 V3 is equals to M2 V2 dash. M2 V2 dash. Now M3 equal to M2 V2 dash by V3. M2 V2 dash by V3. Okay, M2 already you will get from the step 2. This is from step 2. How much molarity you will get? That is M2, and the V2 dash is how much amount of EDTA consumed. Okay, how much amount of EDTA consumed, and V3 is volume of hot water. Okay, how much amount of sample we are going to pipette out. That is V3. By substituting all this, you will get the M3, molarity of hot water sample. Molarity of water sample. Now we need to know total hardness. How we are going to find out the total hardness is, we have the formula to find out the total hardness. Okay, whatever the M3 we got, molarity of hot water into 100 into 1000. This is the formula to calculate the total hardness of water. Formula to calculate the total hardness is M3. Okay, by substituting the values, you will get the M3 into 100 into 1000. 100 into 1000. By substituting the values of M3, and we need to multiply with 100 into 1000, you will get the total hardness. Okay, total hardness. This is the way you will calculate the total hardness of water. M3 into 100 into 1000. Okay, whatever you will get now, that is total hardness in ppm. Total hardness in ppm. Total hardness is equals to M3 into 100 into 1000. M3 into 100 into 1000 is a formula to calculate the total hardness in ppm. Total hardness in ppm. Now step 4 is permanent hardness of water is calculated by. Permanent hardness of water is calculated by. Okay, formula to calculate this permanent hardness is, okay, M4V4. Okay, M4V4 equal to M3. Okay, M2V2 dash. Sorry, M2V2 double dash. Okay, V2 double dash. Okay, here we need to find out M4. M4 equal to M2V2 double dash by V4. M2V2 double dash by V4. Now already you will get M2. Okay, M2 here is EDTA molarity. Step 2 ma. M2 is EDTA molarity. M4 is, we need to find out the molarity of boiled water. Okay, in the step 4 what we have taken, we have taken 100 ml of water sample. Okay, water sample, and we have boiled it for not to 100 ml, have to reduce it to 50 ml. 100 ml has to reduce to 15 ml. Till that we need to boil, and we need to cool the solution. We need to pipette out 20 ml of solution from this 50 ml. We need to 20 ml of solution, and we need to add 2 ml of buffer and 2 or 3 drops of indicator. You will get the wine red color complex, that is the unstable complex. To that we need to titrate with EDTA, which we are going to take in the burette. Okay, here wine red color complex turns to blue color, that is the end point. Wine red color complex turns to the blue color, that is the end point. Okay, now we need to take the end point reading, and we need to find out the concurrent values 2 or 3 times. At least you need to get same value for 2 or 3 times. Now this is a formula to calculate the permanent hardness of water is calculated by M4V4 is equals to M2V2 double dash. Here we need M4. M4 is equals to M2V2 double dash by V4. M2V2 double dash by V4. Okay, here M2 molarity of the EDTA you will get in the step 2. How much molarity you will get? No, that is we need to write here M2 into V2 double dash is how much amount of volume of EDTA consumed. Okay, burette readings. This is burette readings. Okay, wherever the wine red color turns to blue color, that is the end point. Okay, how much amount of the volume of EDTA has been consumed, we need to note down. That is V2 double dash is volume of EDTA consumed, and M4 is molarity of boiled water. V4 is volume of boiled water. How much sample we have to put out? 20 ml. If 20 ml you have take, that we need to note down 20 ml, 10 ml, 10, 30 means 30. How much amount of volume of boiled water we have pipette out from the 50 ml, that we need to note down here. By substituting all these, you will get M4. M4 equal to M2V2 double dash by V4. Now here we need to find out permanent hardness. Permanent hardness, to calculate the permanent hardness, here the formula is M4, whatever the fourth step, molarity of M4 you got, no, that into 100 into 1000. Okay, M4 into 100 into 1000, you will get ppm. Permanent hardness you are going to find out by M4. Okay, here total hardness is by using M3 into 100 into 1000. Permanent hardness by M4 into 100 into 1000. M4 into 100 into 1000 in ppm. Permanent hardness is M4 into 100 into 1000 in ppm. Now, temporary hardness of water sample, we don't know. Already we got in the step 3, we got total hardness. Okay, in the step 4, by using M4 into 100 into 1000, we got permanent hardness. But we need temporary. Okay, we have the formula that is total hardness equal to temporary plus permanent. Total hardness equal to temporary plus permanent. Okay, in the step 3, okay, by substituting M3 into 100 into 1000, we got this total hardness. From the step 4, we got the permanent hardness, but we don't know the temporary hardness. Temporary hardness is nothing. How we are going to find out this temporary hardness is temporary hardness equal to total hardness. Okay, this we got from the step 3. Total hardness minus permanent hardness. Total hardness minus permanent hardness. By substituting this, you will get the temporary hardness. Temporary hardness. Total hardness minus permanent hardness, you will get the temporary hardness. Okay, this is the step 4. M4 equal to M2 V2 double dash by V4. Okay, here M2 is the EDTA molarity, that is step 2. How much molarity we got in the step 2, that is EDTA molarity. V2 double dash is the volume of EDTA consumed, and V4 is the volume of boiled water. Volume of boiled water. This is the experiment to determine the how much hardness present in a given sample of water by EDTA method. Okay, ethylene diamine tetraacetic acid is a complex structure. Complex structure. Here, this is what here we are taking EDTA method, hard water sample, and EBT indicator, buffer solution. Okay, the use of this buffer solution is maintain the constant pH. This is the what we got is wine red color, messy wine red color solution. Okay, what we need to take, the step 1 is we are going to take the here in step 2 hard water, whatever the solution we have prepared in the step 1. We got the molarity, that is M1 is equals to the molarity of the step 1 is 0.01 molar. Okay, this sample we are going to take in the this conical flask, and to that we are going to add EBT indicator and buffer solution. Buffer solution, you will get the wine red color solution. This is the unstable complex. To that, okay, we are going to titrate with EDTA. This is the EDTA. Okay, see, this is a EDTA, ethylene diamine tetraacetic acid. Same thing. Okay, instead of H plus sodium salts of EDTA we have taken because it is easily soluble in water. Now this EDTA we are going to take in the burette. Okay, this EDTA we are going to take in the burette. Okay, by adding this EDTA, okay, whatever the wine red color now turns to the blue color. See the blue color after adding it turns to the blue color. This is the end point. Blue color complex is the end point. Now we need to stop the reading and we need to note down the reading. This we need to repeat for the 3 steps. Step 1 is we are going to find out the molarity. Step 2, we need to follow the same procedure. Step 3 and step 4. but we are taking different samples of water. Okay. Step 2, we are going to take the step 1 solution. Step 3, tap water. Step 4, boil water. Step 4, boil water. This is the method to find out. We need to estimate the hardness of water by complexometric method, EDTA method. Okay, hard water, to the hard water we need to add EBT indicator and buffer solution. Okay, buffer, what is the mixture of buffer solution, ma?
Ammonium chloride and ammonium
Ammonium
hydroxide.
hydroxide. Right, very good. Okay, here EBT is the blue color indicator, ma. Here buffer is the white color. We will get the white color acidic solution. Okay, acidic solution, this one. EBT is a blue color. Sample of water, different samples. Here hard water is, we are taking different samples. In the step 2, step 1, okay, step 1 solution, whatever prepared the molarity of M1, that we are going to take in the step 2. Step 3, we are taking the tap water, and the step 4, we are taking the boiled water. Boiled water. Okay, same procedure we need to follow. Okay, take the sample water or hard water. To that we need to add EBT indicator and buffer solution. You will get the winded color complex, that is the unstable complex. Now we need to titrate with EDTA. Okay, EDTA. Okay, ethylene diamine tetraesteric acid, that we are going to take in the burette. See here, the burette we have EDTA solution. Okay, EDTA now, as we are adding to this winded color complex. Okay, the winded color complex, unstable complex, turns to the blue color. Turns to the blue color. That is nothing but end point. End point. Like this, we need to do for 2 or 3 times. Like at least 2 values should be concurrent. Okay, concurrent values to be get, means similar values. Similar values we need to get. Like that, we need to repeat for the step 2, step 3. Okay, and step 4. Same procedure we need to repeat, but the sample we are taking is different. Okay, in the step 2 we are taking the step 1 solution. We have prepared the molarity of hard water, and the step 2 is we are taking the tap water, and the step 4 is boiled water. That is a different one, but the remaining procedure is similar. Now if anyone is having the doubts, you can ask. Okay, the picture also it is given. This is the winded color complex, ma. Okay, the left one is the winded color. The same principle we are following. Metal ions, okay, calcium or magnesium ions react with, yeah, tell me, Rohini Reddy. Metal ions present, that is calcium or magnesium ions, reacts with EBT indicator. Okay, EBT indicator, it forms winded color complex, which is the unstable complex. Now to this we are adding EDTA, okay, which we are going to take in the burette. It forms, okay, calcium EDTA or magnesium EDTA, which is the, okay, blue color, okay, colorless stable complex, blue color one. The same principle we need to follow for the 4 steps. Okay, sorry, in 3 steps. First step is preparation of standard hard water. Okay, the step 2, standardization of EDTA solution, standardization of hard water, and standardization of permanent hardness of water. In the exam, if they ask estimate the hardness of water, you need to explain all this principle, procedure. Okay, chemicals, principle and procedure. This is metal ion EDTA complex, metal ion EDTA complex. All this we need to discuss. Okay, this, what is EDTA, what is EBT? Okay, EBT is an alcoholic solution of erythrome black tea, EBT. The IUPAC name of this one is 1,1 hydroxy 2-naphtho azo 6-nitro 2-naphthol 4-sulfonate. So 4-sulfonate. it is used as an indicator. It is used as an indicator. Okay. The use of this one is it helps to change the color from blue to wine red color, wine red color to blue when they complex with calcium or magnesium. The end point of complexometric EDTA titration using EBT as indicator is detected. The color change from wine red to blue color is appeared. Wine red to blue color is the end point. The color changes from wine red to blue color is nothing but end point. Yeah, tell me, Ma, any doubts you have? Any doubts?
No doubts.
I have one more class. Shall I stop here? Yeah, tell me. We'll discuss once again in the next class, Ma. If you have any doubts, we can discuss.
No, sir.
Okay, thank you one and all. Okay.